In the Maxone problem, what we do is we'll go for the for an example where we toss the coin, and when we toss the coin, we'll get head or we'll get tails. So head will be represented by 1 and tails will be represented by 0. Now, what is our objective here in this particular problem? To increase 1. It means to increase number of heads. Okay. Now, what we have done is we have done the toss 60 times, and we have created 6 chromosomes in 60 tosses. So every 10 tosses will create 1 chromosome. So here you can see that 10 toss will create 1 chromosome, another 10 toss will create another chromosome, another 10 toss. So in that way we have 60 toss available that we have done, and we have generated the initial population. Now, once we have generated the initial population, you go to the algorithm. After getting the initial population, what is the next step? Next step is calculate fitness. Let's see how we have calculated the fitness. Fitness is, as I told you, in the Maxone problem, we have to find out maximum number of 1. Yes. So it is, this particular fitness function is based on how many ones we have in that particular chromosome. So in that particular chromosome, how many 1 we have? So it is 1, 2, 3, 4, 5, 6, 7, 7 1. So that's why the fitness value is 7 here. Here we have 5 1, we'll get 5 as the fitness value. Here we have 7 1, we'll get 7 as the fitness value. Here it is 4, 4 is the fitness value. Here we are getting 8, 8 as the fitness value. Here we are getting 3, so 3 as the fitness value. Now, what is the total? If we do it a total, we'll get 34. How much we'll get? We'll get 34. Now, after getting the total fitness value as 34, we'll find out the percentage. Now, could you tell me what is the percentage here for this value, 8? So what we do is, we'll just open the calculator and we'll calculate what is for 8. So how will I find out for 8? So it is 8 divided by 34. 8 divided by 34. So it is of percentage is 23%. Here it is for 23%. Now 7 divided by 34, it is 20%. This is 23%. Here it is 23%. So here it is 23%. For 7 it is 20%. Here it is 20%. Now again this 7 is 20%. This 4 is around 11%. This 5 is around 14%. And this 3 is around 8%, you can see. Okay, so you'll find out that there are 20%, 23%, 20%, 14%, 11%, 8%. In that way, we are getting some value. Now, after that, getting the fitness function and the percentage of it, will go for the selection. So how will select? So here, the selection process will be done by a method which is called roulette wheel. So roulette wheel will use. Roulette wheel is you have seen in the casinos and you have seen in many games. Like there is a fixed point, and we'll what we do is we move this particular wheel, and once it will come to a block, so that block is selected for the let's say the game and all. So here when we create this roulette wheel, we create based on the percentage. So if you'll see what is the greatest percentage is 23. So 23% of the wheel wheel structure will be dedicated to S5. So let's say you assume that this is for S5. Now the next is 20. Let's say the 20 is here, S1. Let's say the 20, again 20 is S3, or this one you can say more is more, or S2 is for, let's say, the 14, and for S4 some value, and for S6 for some value. So if you will round, or if you will rotate this particular roulette wheel, so definitely we have the chance to get that particular point for the greater percentage of the chromosome. So the selection for that criteria will be fulfilled. So randomly, if will rotate this particular wheel, so definitely you will find out that S5 will come many times, right? And there is a probability to come this S5 many times. So the same thing will apply here, and we'll select it. So you see here, after selection process, we get some chromosome. So you see here, this particular chromosome, which is S1 dash, will be come up with S1. So first we have done, so we got S1. Second rotation we have done, so we got S3. So we'll take S3 as the second chromosome. Now again we'll done the rotation, we get S5. So the third chromosome we have taken from S5. Then again we have done the rotation, so we get S2 at that particular time. Again we do the rotation, so we might get S4, let's say. And again we'll do the rotation, so we'll get S5 again, because S5 has the greater percentage, so definitely it has the chance to get 2-3 times. So it is getting 2 times. So S5 is getting 2 times. S1, S2, S3 and S4 are getting 1 time. It doesn't matter whatever it is. It is randomly selection based on the fitness. So which is having the least fitness will be left out and will not do any crossover. Now after selecting this particular, we'll put some new name for that chromosome. Okay, even though we have generated the chromosome from the previous one, we have given the new name. Now after doing that, what we do the crossover. For the crossover here, we'll do the crossover to the 60% of the population. So let's assume that from this 6, let's say 4 chromosome will take for the further crossover, and 2 will leave for the, will not do any crossover for 2 chromosome. So the first 2 chromosome will take for the crossover, and the last 2 chromosome will take for the crossover. Now if we'll take first 2 chromosome for the crossover, we'll take again the crossover will do with the with this particular single point crossover. So we'll do the single point crossover. Here the value is 2. So we just divide the chromosome into 2 raised to less, which is left. So 2 raised to 8. So 2 raised to 8 we divide. So what will happen is we take the value of 1, 1, and after that we take the value from this S2 dash. This is 1, 0, 1, 1, 0, 1, 0, 0 in that way. For that, we do the same thing. We'll take the first 2 value and we'll take the last 8 value from this side, and we'll get this value. So in that way, we do the crossover. For S3 and S4, we do not do any crossover, so it is as it is. For S5 and S6, we take the value as 5 raised to 5. So we are dividing it into 5 raised to 5. So what we are doing is, first 5 gene we are taking from one, another 5 gene we are taking from another chromosome. So in that way. So it is 0, 1, 0, 0, 0. That is 0, 1, 0, 0, 0. And after that we'll take 1, 1, 1, 0, 1. 1, 1, 1, 0, 1. And we'll make another chromosome. That is the child chromosome or the crossover chromosome or the new chromosome. Now for S6, we'll take 1, 1, 1, 0, 1. That is 1, 1, 1, 0, 1. And we'll take this part, that is 1, 0, 0, 1, 1. 1, 0, 0, 1, 1. And we'll generate another child from crossovering. So crossover will generate again population. So this is my new population after crossover. Now in this, what we do some mutation. Mutation, as I told you, to increase the chance of getting the increasing the fitness value. Now here, this 1 will be replaced by 0. This 0 will be replaced by 1. This 1 will be replaced by 0. This 1 will be replaced by 0. This 0 will be replaced by 1. Here, this 1 will be replaced by 0. So in that way, we do some mutations. Mutation will do to increase the fitness. It might lead to decrease the fitness also. It is a random process. Okay. So the mutation will be done and we'll get the population. Now, if you will calculate the population of this, so this population is giving you some fitness value. What is the fitness value for S1 triple dash? It is 1, 2, 3, 4, 5, 6, 7. So it is 7, right? It is 7. So I'll give the value 7 here. Now, what is the fitness value here? 1, 2, 3, 4, 5, 6, 7. This is also 7. What is the fitness value for this chromosome? 1, 2, 3, 4, 5, 6, 7, 8. This is 8. Now, what is the fitness function here? It is 3, 4, 5. Here it is 5. What is the fitness function value here? 1, 2, 3, 4, 5. This is 5. What is here? 1, 2, 3, 4, 5, 6. Here it is 6. So you see how much you are getting? 7 plus 7, 14. 14 plus 8 will be 22. 22 and 5 is 27. 27 and 5 will give you 32. And 14, 18 is 15. 15 and 10, 25. 25 and 30 is, yeah, so 1 is what we have, 1, 2, 3, 4. Okay, this is 6 actually. This is not 7, this is 6. This is 6. So how much you are getting? You are getting 37 as the fitness value. So here what you are getting? 34 as the fitness value. Here you are getting 37 as the fitness value. Means you are increasing the fitness value. So we are going to the right direction. So let's assume that what is the greatest fitness value here? Because we have 60 chromosome. So definitely number of 1 should be 60. So 60 will be your maximum. But we to getting 60, it is very difficult. So let's assume that the fitness value is, let's say, 45. So if we'll reach the fitness value 45 at that particular time, we'll end the iteration of genetic algorithm in that particular graph. So we will stop this particular iteration once the fitness value is 47 or more than 47, if we'll select the fitness value is 47. Now what it is saying, in one generation, this is one generation, right? The total population fitness change from 34 to 37 thus improved by 9%. At this point, we go through the same process all over again until a stop criteria is met. Okay, so until the stop criteria will met, this genetic algorithm will go on till refining our chromosome so that we'll get the desired fitness value.